Let's start with the first unit now. Our first unit is fundamentals of mechanism. In this unit, we are going to study kinematic links, types of links, kinematic pairs, types of constraint motions, types of kinematic analysis, kinematic pairs, kinematic chain, types of joint, mechanism, machine, degree of freedom, Goodbatch criteria, Grobler's criteria. After that, we have to do the complete understanding of 4-bar chain and its inversion, then Grashoff's law, slider crank chain and its inversions, then double slider crank chain and its inversion. So this is the content of our first. Before starting with the kinematic link as a first part, we will first of all start with the mechanism. So first of all, we will understand mechanism. What is the mechanism? What do you call mechanism is? Then we will go for the remaining things. So as a starting, we will start with the mechanism. Now before starting with the mechanism, definition of mechanism, we will see one example of the mechanism, then we will see why it is known as a mechanism. So this is a mechanism. This mechanism is known as slider crank mechanism. What this mechanism is called? Slider crank mechanism. Now slider crank mechanism consists of a crank, then slider and element or link which connects slider with the crank. So this is known as connecting rod. What it is known as? Connecting rod. Let's see the working of this mechanism. The working of this mechanism is very simple. When crank rotates by certain angle theta from the mean position, then your slider will slide or reciprocates. A slider will slide or reciprocate, right? So what is the crank? Crank is the element which can rotate through 360 degree. Okay, so crank is a rotary element or rotary link which rotates through 360 degree, where slider is a reciprocating member. Slider is what? Reciprocating member. Slider is reciprocating member. And what is connecting rod? Connecting rod connects the slider with the crank, and the motion of this connecting rod is oscillatory motion. Oscillatory, which oscillates. Okay, which oscillates. Now let's see why it is called as a mechanism. Why this is called as a mechanism. So let's see the definition of mechanism. What the mechanism is? If number of bodies are assembled in such a way that the motion of one causes the constraint and predictable motion to the others is known as a mechanism. This is the definition by S.S. Rath. So if number of bodies are assembled in such a way that motion of one causes constraint and predictable motion to others is known as mechanism. Now why our 4-bar chain or a slider crank is a mechanism? Let's try to understand with respect to this definition. Okay, so what our definition says first, if number of bodies or links, another name for bodies is nothing but links. Okay, number of links. Now how many links are there? The first link is nothing but fixed link, which is known as frame. I will mark it by that. So whatever fixed points are there, that is known as a frame. Okay, frame is link number. To the frame we are connecting crank. So crank is nothing but link number. What is the link to crank? Is link number. Then third link is nothing but your connecting rod. So connecting rod is nothing but your third link, and fourth link is nothing but your slider. Fourth link is slider. Okay. So how many links are there total? 4 number of links or bodies are there which are assembled. How they are assembled? They are assembled in such a way that means crank is connected to the frame, then crank is connected to the connecting rod at one end, and another end of the connecting rod is connected to the slider. That is nothing but assembly of these 4 links in such a way that motion of one. Now if we consider crank as our first input motion, that means if I move the crank in a particular direction, let's see here, clockwise, by angle theta is equal to 30 degree. By angle theta is equal to 30 degree. Then what will be the constraint motion of the slider? Slider will start reciprocating either in right direction or left direction, which is constrained and predictable. Predictable means we can find out the actual velocity of slider if we know the lengths of our link, that is length of the crank, length of the connecting rod, and this angle, if it is known to us, we can easily predict the direction and magnitude of the velocity of slider. Okay. So in our case, a number of bodies are assembled, first thing. Second, the motion is constrained, and third, the motion is predictable. When these three criteria are satisfied, that particular connection of links is known as a mechanism. Here we cannot connect our slider like this. There should be a proper assembly. Slider cannot be connected over here and then connecting rod. It's not the case. Connecting rod is connected to the fixed link. This will not be the mechanism. To the mechanism, the assembly should be such that the motion should be constrained and it should be predictable. Then it is known as a mechanism. What mechanism does? A mechanism transmits and modifies the motion. Mechanism transmits and modifies. Now in this case, we can say that rotary motion of the crank is converted to the reciprocating motion of the slider. Reciprocating motion of the slider. So rotary motion is converted to the sliding motion or reciprocating. So this is nothing but our mechanism. Okay. Now examples of mechanism. Examples of mechanism. What are different examples of mechanism? So right now we have seen the example of your slider crank mechanism. Slider crank mechanism. Very simple example we have seen. There are many day-to-day life mechanisms are there that we are handling. Okay. Another example we can see is nothing but the compass. That is also known as a rounder. So for what purpose we are using it? Rounder. To draw a circle. Isn't it? To draw a circle. That means we are having a rounder like this. We can put at this edge there will be a point, and at the another end we are connecting pencil over here. Okay, we are having a pencil. So whatever distance we are taking here, that will be the radius of circle. Now in this case, we can see this is our link 1. Okay, this will be our link 2. Okay? And these two links are connected over here with the help of a pair known as a turning pair. Then how we are drawing the circle? We are keeping this point at the center. We are taking the distance equal to radius of the circle, and we can simply revolve it about this fixed point, and we are getting a circle. So this is nothing but a compass or rounder, that is also known as a mechanism. Third is nothing but our hand. If we consider our hand is connected to our body through shoulder. Okay, so I can consider this as a shoulder. Okay. Then at the elbow, this will be our second link, and this will be our arm. Okay, these are the fingers. So here there will be a ball joint. Then I can consider it as a link 1. This will be your link 2, and this will be your link 3 over here. Link 3 itself is connected to the number of fingers, so we can increase number of links over here. Correct? So this is also a mechanism, so that we can handle a particular weight, we can move a particular mass from one place to other. The same thing is used for the robotic arm. Whatever robotic arms are there, which are actually inspired by our hand. Okay, robotic arms. The robotic arm and hand are nothing but the examples of the mechanism. Another very simple example we can consider is nothing but scissor. Scissor that we are using to cut certain piece of cloth. So if we see, this will be the simple diagram of our scissor. Okay, these two links are there at the center or at particular preferred point, which is having a turning. That means this is link number 1 and this is link number 2. These two links are connected at a particular point, and we can do the cutting operation. Okay, so this is nothing but also simple mechanism. So these are very day-to-day life applications or examples of the mechanism. Now in the next part we will see what is the machine.